Good morning. Today we are going to discuss indexing structures for files. Indexing, just like our indexing in a book, there are a number of chapters, and in those chapters we have secondary indexes like that. How files can be indexed? That is the point of discussion today. And the chapter outline is like this: types of single level order indexes. Single level order indexes means primary indexes, secondary indexes, or clustering indexes. Then multi-level indexes are also there. Then today we are going to discuss that much only. And dynamic multi-level indexes using B trees and B plus trees are also possible, and index on multiple keys are also possible. So today our discussion is limited to single level indexes as well as multi-level indexes. Okay. Now indexes as access paths. A single level index is an auxiliary file that makes it more efficient to search for a record in the data file. An index is usually specified on a field of the file, although it could be specified on several fields. One form of an index is a file of entries, field value and pointer to the record which is ordered by the field value. Index is called an access path on the field. In our books we have an index. Suppose that a keyword you want to find, and that keyword is given, and after that the page number in which that the details of that word is there, that is an index. Just like that, here also we are going to have indexes. Here see, the index file usually occupies considerably less disk space blocks than the data file because its entries are much smaller. Binary search on the index field of a pointer to the file record. Indexes can also be characterized dense index or sparse index. That means, for example, suppose that you have a record and that you have a student record, and suppose that for every student record there is an index entry, then we call it as a dense index. That means for every record or for every block, if there is an index, then that is called dense index. A dense index has an index entry for every search key value in the data file. A sparse index on the other hand has index entries only for some of the search key values. Suppose that you have an ordered list, and suppose that you can have a statement like say 1 to 5. You should have some index, then 6 to 10 some other index, and 11 to 15 some other index, and something like that. So for 1, 2, 3, 4 etc. up to 10, for each of the entries 1, 2, 3 etc., suppose that we have an index entry, then we call it as a dense index. And if for 1 to 5 we have an index, and for 6 to 10 some other index, and something like that, then we call it as a sparse index. Sparse index on the other hand has index entries for only some of the search values. See, indexes also access paths. Given the following data file employee, and that employee has employee name, social security number, address, job, salary, etc. And suppose that the size of a record size is 150 bytes, and a block is having block size equal to 512 bytes, then say 512 divided by 150 is equal to how much? Is equal to 450 plus 62 wastage. So in a block we can keep 3 records. So for storing 30,000 records you need how many blocks? 10,000 block you need. That means the blocking factor is B divided by R, 512 divided by 150 is equal to 3 records per block, and number of file blocks is equal to 30,000 divided by 3. You need 10,000 blocks for storing 30,000 records of employees, and each record is having a size of 150 bytes. For an index on the SSN field, suppose that I am going to have a social security number, and depending on that social security number I am going to have an index, and for each social security number you should have a pointer to the block in which it is stored. assume that the field size VSSN, that means the value of that is 9 bytes, and assume that the record pointer size, that means it is pointing to a pointer to the block or pointer to the record in which it resides, and that point is having 7 bytes. A total of 9 plus 7, 16 bytes are there for an index entry. So here, as it is a dense index, then for these 30,000 records, you should have, for each record you should have an index entry, and that means for 30,000 records you need index entries. So how many indexes can be stored in a block? That is blocking factor. Again, index blocking factor BFR1 is equal to B divided by R, 512 divided by 16, 32 entries per block. That means you can store 32 index entries in a block, 32 blocks, and number of index blocks, that means in every block you can store 32 indexes, and a total of how many indices are there? 30,000 index values are there. So 30,000 divided by 30 is 938 blocks are needed for storing the index. So you need 10,000 blocks for storing the data, and 938 blocks are for storing the index. Suppose that you are going to have a binary search on these 938 blocks. You need log 938 to the base 2, that means 10 block accesses. That means 10 block accesses are needed for retrieving that particular pointer from this. Okay, this is compared to an average linear search cost of B by 2 is equal to 15,000 block access. Suppose that if we are not having any indexes, then for accessing a particular record which is having 30,000 blocks, you should have an average of B by 2, that means 15,000 block accesses. If the file records are ordered, suppose that these file records are ordered, the binary search cost would be log B to the base 2, log 30,000 to the base 2, it is 15 block accesses are needed. If you don't have an index, then you need, if it is an ordered file, then you need 15 block accesses. But here we have 938 blocks for storing the index value, and in that index, for searching a particular record, you need only 10 block accesses. Then types of single level indexes. Primary index defined on an ordered data file. Primary index should be defined on an ordered data file, and that data file is ordered on a key field. For example, suppose that your register number, your admission number, those are all using that you can have an ordered data file, and the data file is ordered on a key field. Includes one index entry for each block in the data file. The index entry has the key field value for the first record in the block, which is called the block anchor. A similar scheme can use last record in the block. A primary index is non-dense, or it is a sparse index, and since it includes an entry for each disk block of the data file and the keys of its anchor record rather than for every search value. So when you are discussing an example, you should be aware on this is an example. See, here you have a data file and you have a number of blocks. In the first block on the right hand side, the first block are the name of the person you have to verify. In the first block you have Aaron ED2 Acosta Mark, and in the second block you have Adams John to Akers Jan, and third one Alexander to Alan, and the fourth one Alan to Anderson, etc. So these are kept in a block. That means in a block you can have multiple records, and see here the index file you have to see, and in the index file here in the first block the anchor record or first record is having the name Aaron ed, and that entry is there in the primary index, and Aaron ed and pointer to the first block is given there. And see the second one there, second block there, the first record is having the primary key field Adams John, and that is the anchor record there, and that entry has to be kept in the index file. That means Adams John, and that is pointing to the second block. And likewise the first entry in the third block is Alexander ed, that also has to be kept or there in the index file. So index file is not having the details of all the records in the block, and in every block you have a block anchor. That means the index entry for the first record or primary key for the first record in that block. So that has to be recorded on the recorded as the index key, and pointer to the block is there. And likewise, that means for every record you are not having a pointer, and as this is an ordered file, then if you want to search for a particular record, and by searching this index file you can locate the block in which it resides, and in that block you can easily retrieve that information. This is primary index. Okay. Type of single level indexes. So this is the primary index on the ordering key field. Now clustering index. Second one is clustering index. The clustering index is also defined on an ordered data file. The data file is ordered. No, this is not ordered as the case of the first one. That means this is ordered depending on the primary key field. That means Aaron ed Abbott. That means the as per the sorting order of the names only these are kept. But unlike this, in a clustering key field, clustering index, here instead of sorting this on a candidate key field, we are going to order this on a non-key field, unlike primary index, which requires that the ordering field of the data file have distinct value for each record. Includes one index entry for each distinct value of the field. The index entry points to the first data block that contains the record with that field value. It is another example of non-dense index where insertion and deletion is relatively straightforward with a clustering index. So these things, when you are doing an example, you will be thorough with these. For example, here the clustering field value is 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay. Now these are ordered depending on the department number. That means department number is not a primary key because it is not unique. That means department. So all the records corresponds to department number 1. If that field is 1, then that has to be kept contiguously. After that, department number 2, and all the records corresponding to department number 2 is stored in contiguous locations. After that, all the records which is having department number 3 are stored, and like that. That means the clusters are formed depending on the department number, and that department number is not unique. Department number 1, all those are kept in as a cluster. Department number 2 is stored as a cluster, and like that. So this is the clustering key value. Now department numbers are varying. Suppose that you have 6 or 7 departments. Now 1, 2, 3, 4, 5, 6 and 8. We don't have a department number 7, and all those are kept here. And Here we have a block pointer in which that means 1 is pointing to a block, and in which that is the block number, and in that block number you have the starting point of, that means clustering, that means the all the records which is having department number 1 is stored starting from that block value. Okay. 2 is also pointing to the first block because all the department numbers or the second cluster is also starting from the first block. Third cluster is starting from the second block. Fourth is starting from the third block. Fifth is starting from the fourth block. Sixth is starting from the next block, and 8 is starting from the next block. Okay. See, the first block is starting from the first block, and in that we have only 3 entries, 1, 1, 1. After that, the second cluster is also starting from the first block. From that starting point, you have only 2 records. 1 record is in the first block and 1 record is in the second block. See the third one. Third one is pointing to the second block. In the second block, you have 3 entries which is having department number is equal to 3, and in the third block also you have entries which is having department number 3. And this is the way, that means this is also a non-dense index or sparse index, because here department number 1, this department number is not unique. That means all the records which is having department number 1 is stored in a contiguous locations, and the anchor record of that is stored here. It is not actually the anchor record, actually that cluster number, that means 1 is pointing to this block number, means the cluster which is having this value 1, that is pointing to the first record. The first record of this cluster is residing on this block. That's the meaning. So every time a cluster is formed on a non-ordering key field, that means not a unique key. Okay. The next one is another cluster index on example. That means here 1 is pointing to a block, and that block is having 3 records. 2 is pointing to the second block, it is having only 2 records. 3 is pointing to the next record, and it is having 4 records, and some like that. See, here for the first record, suppose that at most 4 records can be stored in a block. Suppose that at this point in time, our assumption is only 4 records can be stored in a block. So in the first block, you have only 3 records which is having department number is equal to 1, so there is no possibility of overflow. In the second block, you have only 2 records which is having department number is equal to 2. In that case also we don't have any overflow. And in the third block, see, in the third block we have 4 records which is having the key value department number is equal to 3, and 1 more record is also we have to store. In that case, there will be overflow in this record, and in that case a new block is allocated, and that block is pointed to by the last. Here we have a block point in the third block, and that block point is pointing to the newly allocated block. So in that case, that means if there is an overflow, a new block is allocated and a pointer to that block has to be kept. This is the way we are going to store. This is another example of clustering index. Now, type of single level indexes. Now next is secondary index. So type of single level indexes are number 1 primary indexes, clustering indices, and secondary indices. Single level indices. Now we are going to discuss second index. A second index provides a secondary means of accessing a file for which some primary access already exists. A secondary index may be on a key field which is a candidate key and has a unique value in every record, or a non-key with duplicate values. An index is an ordered file with two fields. The first field is of the same data type as non-ordering field of the data file, that is an index file. Second field is either a block pointer or a record pointer. There can be many secondary indices and hence indexing fields for the same file includes one entry for each record in the data file, hence it is a dense index. So unlike primary index and clustering index, primary index and clustering indices are non-dense index, and here it is dense index. Okay, that means dense index means for every record there is an index value. When we go through the details of the second index, see here these are the indices values from 1 to 24. For every index, that means 1 to 24, all these are different pointing to different records. See, index field value 1, the block pointer is pointing to the third block. It is not pointing to third block, it is actually pointing to the fourth block. And in the fourth block we have a record which is having the indexing field 2, indexing field 1, indexing field 1. See the second index. Second index is pointing to block number 3, and in that block number you have a record which is having the index key 2. And see, for the third index value 3, that is pointing to, third one is pointing to the second block, and in the second block you have a record which is having 3 as the indexing field value. And like that, for every record there is an entry in the index file, and that's why this is a dense index file. Now this is another way of secondary level indexes. Now here the field value, that means initially you have a non-ordering key value. The field value here 1, suppose that it is department number. It is a non-ordering key value, and that is pointing to a block of record pointers. A block of record pointers is 1. See the first field value 1. There is a block pointer, and that is pointing to a block. And that block is having a number of record pointers, and each record pointer is pointing to an actual record. It is pointing to an actual record. C1. See here in the block, it is pointing to the first block. Another pointer which is pointing to the third block. In that case also we have a record which is having department number is equal to 1. See, the third one is pointing to the fifth block, and in the fifth block you have, that means, so this is the way you are going to have done secondary indices. Okay, so these are the properties of index types. Primary indexes are properties of indices: number of index entries, number of blocks in the data file. Primary index, clustering index, secondary index, non-secondary index. And secondary index can be two types, and the ordering can be based on a key field and a non-key field. Okay, see, these are the things you should always remember when you are talking about indexing. Then multi-level indices using B trees and B plus trees we will discuss later. Okay, thank you.